A very good morning again. This is the second part of my 8th video on mathematics is a language. How is this so? Well, for the math challenged, for that person who has avoided anything but the most basic arithmetic since high school, who feels a pit in his stomach when he sees an equation. That is, for myself, I will attempt to explain with the help of some who do mathematics for a living. If you are maths phobic too, I think you will get a painless feel for why even that master of describing nature with words, the most distinct and beautiful statement of any truth, must take at last the mathematical form. While many early civilizations, including Islamic, Indian, and Chinese, made important contribution to mathematics, it was the ancient Greek who invented much of the maths we are familiar with. Euclid fathered the geometry we named after him, all those radii and hypotenuse and parallel lines. Archimedes approximated pi. Ptolemy created a precise mathematical model that has all of heavens wheeling around the earth. With a few symbols on a page, you can describe a wealth of physical phenomena. But while the Greeks believed that the universe was mathematically designed, they largely applied maths only to static objects, measuring angles, calculating volumes of the solid object, and like as well as to philosophical purposes. Galileo strived to explain how objects fall rather than why, a modulus operandi that set the stage for the advancement of science as we know it today. He sought characteristic of our world that he could measure variables aspects like force and weight, time and space, velocity and acceleration. With such measurement, Galileo was able to construct those gems of scientific shorthand, mathematical formulas which defined phenomena more concisely and more powerfully than had ever been possible before. His contemporary, the German mathematician John Kepler, did the same for the heavens, crafting mathematical laws that accurately describes the orbit of planets around the sun and led to the scrapping of Ptolemy's earth-centric model. A classic example is the formula commonly shown as d is equal to 16t square, what Galileo discovered and ensconced in simple equation, one of the most consequence in the scientific history is that when air resistance is left out, the distance in feet, that is d here, that an object fall is equal to 16 times the square of time. So much mathematics exists now. One scholar estimates that a million pages of new mathematical ideas are published each year. That when scientists face problems not solvable with maths, they know they can often turn to another varieties for help. When Einstein began work on his theory of general relativity, he needed a mathematics that could describe what he was proposing, that space is curved. He found it in the non-Euclidean geometry of 19th century mathematician George F. V. Riemann, which provided just the tool he required, a geometry of curved space in any number of dimensions. With fractal geometry, you can write down formulas that describe rough shapes like trees in contrast to smooth shapes like ripples. Or, if necessary, they invent new maths. When the late mathematician Vinoid concluded that the standard Euclidean geometry, which is all about the smooth shapes, fell short when he tried to mathematically portray rough shapes like bushy trees or jagged coastline. He invented a new mathematics called fractal geometry. Math is our one and only strategy for understanding the complexity of nature, says Rolf Abraham. a mathematician at University of California, Santa Cruz in Nova hunting the hidden dimension. Fractal geometry has given us a much larger vocabulary, and with a larger vocabulary we can read more of the book of nature. Galileo would be so proud. Galileo would also be proud of just how much his successor have achieved with his scientific methods. Formulas from his own on falling bodies to Heisenberg's on quantum mechanics have provided us the means to collect and interpret the most valuable knowledge we have ever attained about working of nature. Altogether, the most groundbreaking, the advances of modern science and technology, both theoretical and practical, have come about through the kind of descriptive, quantitative knowledge gathering that Galileo pioneered and Newton's refined. Newton's law of gravity, for instance, has been critical in all our missions into space. By understanding the mathematics or the force of gravity between the lots of different bodies, you get complete control and understanding with very high precision of exactly the best way to send a space probes to Mars or Jupiter or to put satellite in orbit. All of those things, says Law Stewart, professor of mathematics at University of Warwick in England. Without the maths, you would not be able to do it. We cannot send 1,000 satellites up and hope one of them get into a right place. So please do not worry about your difficulties in mathematics. I can assure you that mine are still greater. Mathematics underlines virtually all of our technologies today. James Maxwell, four equations summarizing electromagnetism, led directly to radio and all other formulas of telecommunication. E is equal to mc square led directly to the nuclear power and nuclear weapons. The equations of quantum mechanics made possible everything from transistor and semiconductor to electron microscopy and magnetic resonance imaging, that is MRI. Indeed, many of the technology you are and I enjoy every day simply would not work without mathematics. When you do a Google search, you are relying on 19th century algebra on which the search engine algorithm are based. When you watch a movie, you may well be seeing mountains and other natural features that, while appearing as real as rock, arise entirely from mathematical models. When you play your iPod, you are hearing a mathematical recreation of music that is stored digitally. Your cell phone does the same in real time. When you listen to a mobile phone, you are not actually hearing the voice of the person speaking. Delvin told, you are hearing a mathematical recreation of that voice. That voice is reduced to mathematics. What calculation were used to build the pyramids? How do suspension bridges not fail? How is landing on the moon possible? In all of these questions lies a solution based in the uses of mathematics. Curious minds have been solving humanity's biggest conundrums for centuries by harnessing the power of mathematics. Seemingly impossible feats are achieved, like landing on the moons or building the tallest tower, and so on. Without mathematics, none of this would be possible. The importance of mathematics can be seen in hidden ways and in everyday uses all around us. Computers, airplanes, body scanners, software, coding, and much more. According to Euclid, the laws of nature are but the mathematical thoughts of God. Mathematics is all around us. As we discover more and more about our environment and our surrounding, we see that nature can be described mathematically.